Welcome everybody, and today I'm going to show you how you can create your very own neural network in PHP. And before we continue, you need to get the Composer dependency manager for PHP. You can get this at getcomposer.org. Okay, once you've done that, we're going to install the Dragons App Neural Network PHP package in a new folder on our desktop. So just in your terminal or command prompt, if you're on Windows, we're going to say composer require Dragons App / neural network :caret 1.0. That will ensure that major 1 is installed. And we now have the library for neural networks in PHP installed. Now inside that folder, you'll see composer.json. This is the composer file for our project. I'm just going to create a new file called main.php. And this will be our PHP file responsible for working with the neural network. Now in this video today, we're going to create an XOR neural network so it will successfully predict an XOR operation. So we're going to open up our PHP tags and we're going to require our vendor autoload file. Now once we've done this, we're going to say neural network equals new neural network. And now what we're going to do is we're going to say use neural network. Just like that. So now we can actually fill our constructor now with the total number of neurons, total output neurons, the learning rate, how many loops we want to do on training, and total hidden layers, and the total neurons in the hidden layer, as well as an activation function such as sigmoid or relu. So the total input neurons, we're going to have it as 2, because this is an XOR model. So we're going to pass in 2 operands and we're going to get an output. So obviously, as you know, with XOR, if you give 1 and 1, you get 0. If you give 1 and 0, you get 1, etc., etc. Our neural network is going to learn the XOR algorithm. And total output neurons, obviously that'll be 1. Learning rate, we can keep that as 0.1. Epochs can be 10,000, that's okay. Total hidden layer neurons, that can be, I guess 10 will be okay for this, more than enough. And total hidden layers will be 1. And then our activation function will stay as sigmoid. So we're now going to fill in these constructor arguments now with the variables that we created. There we go. So next we're going to actually train our neural network. So we're going to say neural network, train network batch, and we're going to train it on 4 records. Okay. So just by here, actually, we're going to say training records, and we're going to say record input. And that's going to be an array. We're just going to have 0, 1, 1, 0, 1, 1, and 0, 0. Okay, so just be 4 records. Then obviously here we can say total records, count training record input. So this is how many records of data we want to train the model on. So this here is our records callback function. Okay, and there's a particular format to follow for this, and we can find it in this test file or this readme. So we can see the function takes a page, a total per page, an input reference, and an output reference. So we're just going to copy this and paste it in. And I'm just going to give you guys a few seconds if you want to just write that down rather than go into the vendor directory. So it's train network batch, we pass in the count, then we pass in this function that looks like this, okay? and it takes a page, a total per page, an input reference, and output reference. And then obviously open up your curly braces for that function. So we're going to say total per page, and we want to do this in one go, just one iteration. So we're just going to put the count of the training record data again. So essentially the whole point we have batches is because if you have millions of training records, you can't just load all that into memory, right? What you can do is you can split it up into batches, like 100, for example. You can pull from the database those records and then pass them as input or output to the actual neural network, right, while it's training. And then it'll sort all of those in a temporary file where it'll then iterate all over them. Okay, so if we were dealing with multiple pages, we would be checking the page number and pulling from the database, as I said, skipping over what we've already done. But for us, because we're doing it all in one iteration, because the total per page is the record input count, we don't have to worry about any of those pages. So we're going to say input equals training record input. We're going to have to pass that as a reference to this function too. So what you want to do is you want to say use, and then we're going to say training record input. Okay. And then by doing that in this little function that we've made, it will pass this data to the function. So we're able to access it. If you don't do that, you won't be able to access the variable because you can't access variables outside of the Lambda function, essentially, right? And again, we're just going to say training record output here. And we're going to put what we expect the output to be. So 0 and 1, that's 1, obviously. 1 and 0, that's 1, obviously. 1 and 1 is 0, and 0 and 0 is 0. There you go. So that's the training record output. So just in here, we're going to say output equals training record output. And again, we need to change our use here. We're going to put a comma and we're going to put training record output. And that'll just ensure that one's passed in here as well. So yeah, that's our training completed. And the final thing to do then is to predict. So what we're going to do after training, we're going to say neural network forward pass, and then we're going to pass in some input. So let's just say that the input is 0 and 1. So we're going to pass in that, and then we're going to have it pass it out to the output. And if we then do print our output, we should see the result of this training. Now, if everything went well, we should see a number that's very close to 1 or is 1. So let's go to the terminal now, and we're going to run our file. And yeah, we can see that this is correct. It's been correctly trained because we have 0.92, which is very close to 1. Let's do 1 and 1 and see if it now gives us something close to 0. And we get something close to 0. So you can see that we were able to successfully train the neural network in PHP. Now let's make this take longer so it's more accurate, right? We're going to put 100,000 now instead of 10,000 epoches. And the epoches are how many times we're going to loop over the data, right? And train the network. So we're now going to run that again. It's going to take longer, obviously, because it's doing more work. And there we go. We can see we're now 0.98 instead of 0.92. So we're much closer to the actual correct result than we were before. So yeah, that is how you make a neural network in PHP. Let's see if we can save the network. So we're going to say neural network, save network, and we're going to say model.json. So let's see if that works. So we're going to run it. And if we now check our folder, we can see model.json. We can see this input file which is a JSON file, and it has all the weights that have been trained. You can see there's weights here, and the weights are used as a way to get the output that we expect. When the weights are correct, we get the output we want. When the weights are wrong, we don't get the output we want, okay? But by saving all those weights to the file, we can actually reload this later on. So what we can now do is instead of saying new neural network and training and all of this sort of thing, what we can say is we can say, first let's say exit, so that none of this code below gets run. So if we run that now, nothing happens, it leaves, yeah? Code will not run. So if we now say neural network equals neural network load network, and we pass in the model.json, and then we now say input equals 1, 0, we say neural network forward pass input output, and then we print out the output, we should now see that that'll work even without retraining, which it does. So you can see once you train the network, you can save it into a JSON file and then reload it later. Now I will say that training the network in PHP is incredibly slow. So I do recommend training Python or something like that and then loading the JSON file later on. If you insist on training PHP, you can, but for large data sets, it could take like 10 times longer than it would take on a CPU. So it is significantly slow. Now, if there's enough interest in this library, I will make a PHP-C module, which will drastically speed up the training because it'll be running directly on the CPU. It won't be interpreted anymore. So let me know if any of you are interested in that, and we can look into that. So hopefully you enjoy this library. Please give some feedback.